Question number 5. A hydrocarbon contains 87.8% by mass of carbon. Well, a hydrocarbon's got hydrogen and carbon in it only. So the only other thing in there can be hydrogen. So 12.2% must be hydrogen. So let's do spoilers and have a look what happens next. So when you've worked out the percentage of hydrogen by subtraction of 100, take away 87.8, then you divide by the molecular mass, the mass of each atom. So 87.8 divided by 12 and 12.2 divided by 1 gives you 7.3 to 12.2. We need these in whole numbers, so the next step is to divide by the smallest, that being 7.3. 7.3 divided by 7.3 is 1, 12.2 divided by 7.3 is 1.67. Now we need to multiply by a number to get this into a whole number. And that's a 3. So if you multiply this by a 3, it'll come out to be a 5. So multiply them both by a 3, 3 to 5. So the empirical formula is C3H5. However, if we add up the MR of each of these, a carbon's mass is 12, 3 12s and 5 1s. For the hydrogens it comes out as 41, and the MR is 82. It's double that. So it needs to be double this, so this empirical formula needs doubling to be its real true molecular formula, which is therefore C6H10. What could that be? Well, C6H10, an alkene is C6H12, an alkene, so take the number of n number of carbons and double it to 2n, but it's even less than that, so it probably means that it's got 2 double bonds in there, not just 1 double bond, but 2 double bonds. So things ways with 2 double bonds with 6, 1, 2, 3, 4, 5, 6. You'd have the double bond at carbon number 1, and then at carbon number 3. You could have the double bond at carbon number 1, and then at carbon 2, 3, 4. Or you could have the double bond at carbon number 1, and then carbon number 5. So you could have hex 1, 3 diene, hex 1, 4 diene, or hex 1, 5 diene. You could even have hex 2, 4 diene as well. So any combination where there's 2 double bonds in a chain of 6 would suffice. You could even have a cyclic compound of 6 with a double bond in there, cyclohexene. And then finally name the type of reaction taking place when bromine water reacts with the hydrocarbon. So what actually happens is if bromine water Br2 would add across the double bond, the Br2 accepts the electrons from the double bond, so a curly arrow would go to one of the Brs, that will come off and attack a carbocation as a mechanism. So that's electrophilic, the Br, the Br2, the bromine is an electrophile and it adds across the double bond, electrophilic addition.